Hello, crazy math nerds. It's the craziest math nerd of all here, Kitty Morgan. We need to talk a little bit about these crazy new graphs we've been given. They've decided to give us graphs of f prime and ask us to talk about f. So they're actually giving us pictures of things, and we're talking about a graph that we cannot see. So it's really important that we interpret what kind of information we need from f prime in order to answer the question that they've asked of us. So this is 1989, number 5, and this is the first one I always do with students. So let's jump in here. So it says in the stem, and remember the stem is the part of the first part of the problem where they tell you everything about this. It says that the figure above is f prime, the derivative. So this is not f, this is f prime. So sometimes we might go right on it and say, hey, this is f prime real big. I know it says it on there, but I need to say it to myself, okay? And then it says, for what values of x does f, not the graph I'm looking at, but f, the graph I can't see, have a horizontal tangent? So your job is to say to yourself, self, what about f prime of x do I know would tell me if f has horizontal tangents? And what we know is that if f prime of x is equal to 0, then f prime has horizontal tangents, right? Then f of x, has horizontal tangents. So what I'm doing is I'm actually writing a game plan for how to look at f prime. But what I'm also doing is I'm writing the justification for how I know this. So this is a way to do two things at one time, to make a plan and then to have your justification. So if I want to know where f prime of x is equal to 0, then I have to say, well, then how do I look at the graph of f prime of x to find the zeros? And that's going to be all the places where the graph crosses the y-axis. That's where f prime of x, that's this graph, is 0. So I see 4 places at x equals -7, -1, 4, and 8. So I made a plan about how do I use f prime to talk about f, and then I had to figure out how do I look at the graph to figure that out. Okay? All right, so I'm taking those off because I might not need those later, but I might. Part B says, for what values of x does f have a relative maximum? Justify your answer. Well, let's say that I've lost my mind for just a minute and I forgot how to find a relative maximum using f prime. So what I'm going to do is I'm going to get my thinking cloud over here and I'm going to think about, okay, what kind of graph has a maximum, a relative maximum? And I'm going to go my favorite little graph, x squared. He's sad in this particular graph because he's upside down, but he is a relative maximum. So what do I know about f prime? And that would be the slopes of the tangent lines around that point. Well, the slope to the left is positive, and the slope to the right of the point, because there's your max, is negative. So I need for f prime of x to change from a positive slope because these tangent lines have, right, from positive because f prime is the slopes, to negative around a point. So could we even use the information we had from our last thing about horizontal tangents, where we had, we had those places right there that I erased erroneously, it looks like. And because those are your zeros, and we know that around zeros, many times graphs change signs. So I need to know where f prime changes from positive to negative, and this graph is f prime. This is f prime. So I'm going to go through this graph and kind of look at it. Starting at negative 10, it is negative until negative 7, like the y value is negative. And I want to know where f prime changes from positive to negative. So actually, I need to know where f prime goes from above the graph to below the graph. And if you'll look at it right here, right in there, f prime goes from above the graph to below. And above means I'm positive and below means I'm negative. So at x equals negative 1, that happens. And again, right here in the section around 8 where it is positive here and negative here. And x equals 1 and 8. So those are the two places where you have a relative maximum, and I've already justified my answer because in my plan, I have justified that that's how I'm looking at the graph to determine what you need from me. Okay, wow, this is pretty neat. Putting this all together is kind of fun. And then part C talks about concavity, and it talks about concave down. So let's draw somebody who is concave down. Oh, I just had him. Little x squared, and let's talk about concavity. What do you know about the slopes of the tangent lines? Because when you talk about f double prime, it's how the guy in front of him changes, and the guy in front of him or the guy before him is f prime. And so f prime means the slope. So what is happening to those slopes? They are decreasing. So if I want to know where f is concave downward, that is when f prime is decreasing. So when the slopes are decreasing, that makes the graph curve to be concave down. And so now I've got to say to myself, how do I look at the graph given to figure out where f prime is decreasing? Well, that's easy, because if you start at negative 10, from negative 10 to negative 3, it is increasing. From negative 3, and I'm going to put a little mark there, from negative 3 all the way down to 2, it is decreasing. From 2 to 6, it is increasing. And from 6 to 10, it is decreasing. So you have to interpret, how do you find out the information they ask you by analyzing f prime? And then you have to figure out how to look at the graph. So f prime is decreasing on the intervals from negative 3 to 2, and from 6 to 10. Okay, so I hope this has helped. You've got to write down a plan, and then you've got to figure out how to look at the graph to get the information. I think the hardest thing about this is you're not actually looking at the graph you're talking about. So it'll take a few of these for you to get used to it. So just keep at it, and the more you do, the better you'll get. Okay? All right, well, I hope this helps. Good luck. Bye-bye.